The Earth is alive, always changing. Continents drift, mountains rise, and oceans are born and die. Right now Africa is tearing itself apart, a continental breakup in progress. This isn't ancient history, it's happening today. Soon, a new ocean will split Africa, reshaping the world map. The ground beneath us is a raft floating on molten rock. Fast forward millions of years, Africa's familiar shape will vanish, replaced by two landmasses divided by a new sea. This is the destiny of Africa, driven by forces deep within the earth. The process has already begun. A great wound is opening across eastern Africa. Earthquakes, volcanoes, and deep valleys mark the land's transformation. From Kenya's geothermal fields to Ethiopia's plains, the evidence is clear. The same forces that once split South America from Africa are at work again. Scientists now know a superplume, a colossal pillar of superheated rock, rises from the Earth's core, pushing up the African crust. This superplume bulges, stretches, and cracks the land, forging a new world. The process is violent: earthquakes, eruptions, and mountain building. We are witnessing the birth pangs of a new ocean. It's geology in motion, a slow spectacle connecting us to Earth's deep history and future. The story begins deep beneath the surface, with heat, pressure, and rock moving on a vast scale. It's a cosmic story, unfolding right beneath our feet. In Eastern Africa, you can stand at the edge of a continent splitting apart. The East African Rift Valley. This isn't a single valley, but a vast system of faults stretching over 3,500 kilometers. It's the front line of Africa's Great Split, where land is pulled in opposite directions. The rift is a complex network: wide, shallow valleys, deep, narrow gorges flanked by volcanoes and cliffs. Some of the world's deepest lakes, like Tanganyika, fill these sunken valleys, early signs of a future sea. The region is alive: steam vents, earthquakes, and shifting ground. In Ethiopia's Afar Depression, three tectonic plates meet and move apart. The Arabian Plate has already pulled away, forming the Red Sea and Gulf of Aden. Now the Somali Plate is splitting from the Nubian Plate. This is the only place on Earth where we can watch a continental rift become an ocean, on dry land. Scientists walk the valley floor, measuring strain and watching new ocean crust form. The East African Rift is a natural laboratory, revealing the forces that shape continents and oceans. Here, we witness the birth of a new world. The process is ongoing, visible, and extraordinary. To understand Africa's split, we must look deep inside the Earth. The surface is broken into tectonic plates, giant slabs floating on the mantle. These plates move, driven by heat from the core, causing earthquakes and mountain building. For years, geologists thought Africa's rift was just plates pulling apart, but the high plateaus of East Africa suggested something was pushing from below. The answer: a superplume, an immense upwelling of hot rock from the core mantle boundary. This plume lifts the continent, weakens the crust, and makes it prone to cracking. Volcanic gases in Kenya revealed a chemical signature matching mantle plumes like Hawaii's. This was the first direct evidence linking Africa's rift to deep mantle forces. The superplume is the engine tearing Africa in two. It pushes up, stretches, and fractures the land. The debate is over deep Earth dynamics drive the continent's breakup. Africa's split is powered from below. Geological change is usually slow, but sometimes Earth reveals its power in an instant. In 2005, Ethiopia's Afar region split open. A 35-mile-long fissure appeared in days. Earthquakes and a volcanic eruption at Dabahu accompanied the event. The ground separated by centuries' worth of movement in just a week. Magma injected underground acted as a wedge, forcing the rift wider. This was a dramatic sign: the continent is actively being ripped apart. Scientists rushed to study the fresh fissure, gaining rare insight into rifting. The event showed that continental breakup can happen in violent bursts, not just slow shifts. Magma doesn't just fill gaps, it drives plates apart. Since 2005, more fissures have opened, confirming this is an ongoing process. The Ethiopian fissure is a visible symptom of immense stress beneath Africa. It's a crack in the world, showing us the future. How do we know Africa is moving? The motion is slow, just millimeters per year. Scientists use high-precision GPS and satellite radar to track the rift's progress. GPS receivers on either side of the rift detect movements as small as a millimeter. Satellite radar creates detailed maps revealing ground deformation and magma movement. These tools let us watch the continent's birth and death in near real time. GPS shows the steady drift. Radar captures sudden changes. Combined with seismic and geochemical data, scientists build a complete picture of rifting. We're not just observing the surface, we're peering deep into Earth's mechanics. What's next for Africa? The rifting will continue, the cracks will widen, and the land will sink. In 5 to 10 million years, the Afar Depression will flood as the Red Sea and Gulf of Aden pour in. A new narrow ocean will form, splitting the Horn of Africa from the mainland. Somalia, and parts of Ethiopia, Kenya, and Tanzania will become a new island continent. Africa's eastern coastline will be redrawn, and a new ocean basin will emerge. This is geological certainty, the outcome of relentless forces at work for 30 million years. We already see the first oceanic crust forming in the rift. Magma rises, creating dense, dark rock, the foundation of a future ocean floor. 10 million years is a blink in geological time. The superplume and tectonic plates will keep driving the split. We are witnessing the first steps of a process that will reshape the planet. The new ocean is inevitable. We live in a privileged moment, able to watch the birth of a sea. Africa's story isn't unique. Earth's continents have split and merged for eons. 180 million years ago, South America and Africa were joined as Gondwana. Forces like those in East Africa today pulled them apart, forming the Atlantic Ocean. The East African Rift is a young version of the rift that became the Mid-Atlantic Ridge. Studying it lets us look back in time and understand how continents and oceans form. The superplume beneath Africa confirms deep Earth forces shape our world. This knowledge helps us predict earthquakes, harness geothermal energy, and find resources. It deepens our connection to the planet, reminding us Earth is dynamic, not static. The ground beneath us is part of a grand, cosmic story of change. We are passengers on a planetary journey, witnessing history in motion. The rift is a living example of plate tectonics, the engine of our ever-changing world. Africa's split is a chapter in Earth's ongoing story. We are here to see it unfold.